In this lecture, we are going to discuss about derivative of a function of complex variable in polar form. We know that w equal to fz is a function of complex variable and it is given by u plus iv also, where u is my function of uxy and p is the function of bxy. xy is further function of r comma theta. Then derivative of w with respect to z is derivative of the function f with respect to z is that partial derivative of w with respect to the variable x or y. Okay. Now w is a function of uv is function of xy is a function of r theta. So derivative of this function in polar coordinates are del w del r del x plus del w by del theta by del x with this equation. Now next we know the relation between polar and Cartesian coordinate is r equal to x equal to r cos theta, y equal to r sin theta. We have already discussed it in arcane plane lecture. So that if you square and 8, it will be r square within bracket cos square theta square and tan theta, that is divide this equation by this equation. I will get r sin theta by r cos theta, r cancel out, this will be tan theta, and in the right hand side it is y by x. This will imply theta equal to tan inverse x. Differentiating partially with respect to x, differentiating DIF stand for differentiating. Write the word differentiating in full in your exam. Differentiating with respect to x and y partially, we get partially. Here I am considering differentiation with respect to x because it is required only. Okay, I need only these two. So differentiate partially with respect to x partially, we get differentiating with respect to x partially, I will get 2x equal to 2r del x. So this implies del r by del x r cos theta. Cos theta. Then again differentiate this. Differentiating theta partially with respect to x. Then first differentiate this tan function, that is 1 by 1 plus y by x square. Then differentiate this with respect to x. X plus y square minus 1 y square plus x square minus y is your r sin theta, that is minus r sin theta by r square. This r cancel out, that means value of del theta by del x will be minus sin theta by r. Now put this value in 1. Put this value in 1, we will get, therefore 1 becomes dw by dz, this del x, and it is equal to del w del r, del r by del x will be cos theta, then plus del w by del theta by del y will be minus sin theta minus sin theta by r. So this is minus sin theta by r, this is cos theta. Now del w by r will be my del u by del r. W is the function of u plus iv. Actually, w is equal to u plus iv. So differentiate that, what you will get this one, I del p by del partial differentiation of u with respect to r and partial differentiation of v with respect to r cos theta. Del v del u del theta plus I del v del theta. Then del u by del r, I am changing this one, del u del r plus I del v del r cos theta minus sin theta by r. Here we know that del v by del r is equal to minus 1 by r del u by del theta. This implies minus r del v by del r is equal to del u del theta. So in place of del u del theta, I am going to put here minus r del v by del r. Then again we know that del u by del r equal to 1 by r del v by del theta, r del u by del r del v by del theta. Then I am putting here I r del u by del r. Here if you take the r common, that is del u del r, I del v del r. Sin theta del v del r del u del r. Okay, this is minus. If I take I common, this is minus 1, there will be I squared. If I take I outside, that is del u del r plus I del v del r. So in next step, remaining all other term will be left as it is. I will change it. Del u del r plus I del v del r cos theta minus sin theta then if I take I common, then it will be del u del r plus I del u del r. This is minus 1 is minus 1, that will be I square. So 1 I taken common, this will be I del v del r. Now if you take this term common, this will be minus, this will be minus, this is minus. because I'm taking I common. I'm taking only I common, not minus. This is minus 1, so it will be I square, and from I here I have taken I common, here I square, so it will be I. So this is minus I. So this is minus I, and this one. Sine theta. Del R I del B del R. This is equal to ei theta from the exponential function. This is equal to cos theta minus I sine theta. And this is my del W by del R, and this is minus I theta. Okay, this is minus I theta minus ei theta, which is the required partial differentiation, that is derivative of a function of complex variable, which is the required derivative of a function of complex variable in polar form. With that, I would like to conclude. Remaining will be in the next lecture.